I woke up in the morning on Saturday and went to the Skills USA thing and passed over.
All right, guys.
What'd you do? Was it just wired circuits?
First piece is a definition we went over last week. I want to just go review this piece. We talked about this piece as well. A function f has an inverse function f inverse if and only if f is a one-to-one function. What's the line test that we do to test that it's one-to-one? Horizontal. Vertical line test is to test if it is a horizontal line test to test that the function has an inverse. All right. Steps, we change it to y.
Nice. It's froze.
There it goes.
Like lag.
All right. Y equals 2x minus 1, and then what do I do next?
You move the x and the y. So you got x equals 2y. Move the 1 over next.
Move the 1 over next.
2y or not 2y?
And that gives me x plus 1 equals 2y.
You know what you do? You got to get rid of that 2. Now what you got to do is when you get rid of the 2, you get rid of the 2, so you get rid of the 2.
Looks like you got rid
We should get rid of the 2.
Get rid of the 2. Okay, give me a second.
Looks like we don't have a 2 anymore.
Hello, Mrs. Torres.
Because
I'm afraid we're all out of twos.
Okay. Bye-bye.
It's like when your mom's talking on the phone and then she gets mad because you're talking too. She can't do the first one.
You want to take a picture of the notes or get them from a phone? Or,
Okay.
okay, or online.
Is there a, yeah,
is there a worksheet?
No, it's in the book. In the book. All right. Now, I told you guys last week, you can write it as a big divide or an individual divide. I'm going to write it as an individual because I want to graph it. And the only thing different, I'm going to write it as an inverse. All right, do we all agree? This is the inverse.
Yeah.
And this is the
So
original.
we end up with, okay, like I get how you get the y equals 1/2 x plus 1/2. But when you get the inverse, you're just changing y to f x inverse, right?
Yeah,
Okay.
just notation. All right, so we are going to sketch 2x minus 1. What's the y-intercept? Right here. What's the y-intercept for 2x minus 1? What's your slope? Up 2 over 1? I do quite a bit just to make sure.
You're fully sent.
And then connect.
Connect. Yeah, connect 1. We're gonna have like this does not pass any of the tests because it's
All right.
line. No lines.
Next one,
It's the single line test.
I'm going to do it in blue. What's the y-intercept?
1/2.
What's the slope?
1/2.
Up 1 over 2?
Sure.
So from the half mark, when you go up 1, you end up with another half mark. Does that make sense? And then over 2.
Oh.
Up 1. What was that? Yes.
Boy, tonight.
Aren't they broken if they cross or something?
Yes.
Is this what we learned on Friday?
We learned how to do it. We learned this part on Friday. And we learned that, I'm going to write it up here. We learned that when you take f of f inverse of x, it always comes out to be what? This was last week's lesson. It was on your homework.
Looks like this doesn't have
Come on, guys.
So what we do is...
This is the
we
question
have
from last week.
Yes, we have the f, so we take what the inverse is, and then we take what f is originally.
But the answer always came out to be
X.
x. Thank you.
There we go.
And the same is true for f inverse of f of x. The answer comes out to be
Just an x. Will it
X.
ever be negative?
if the number in here was negative. If this was negative x,
But
it
it's
would come
not,
out.
'cause it's 2.
It's whatever. So, for example, if I had a 5 in here, f of f inverse of 5 would equal 5.
Yeah.
F inverse of f of 5 would still equal 5.
But if it was negative 5.
If
It's
they
still
were-
same thing.
If they were
Inverses. If they are inverses of each
not,
other.
it'd be like 2 and 6.
Right, right. It's different numbers. So if you plugged in a negative 2, the answer would come out to be negative 2.
Okay, I see.
All right, so we're here. Now, do you guys remember last week on Friday what line I said that they're reflective across? There was a special line I gave you guys. We didn't graph it or anything, but I told you.
Racing line.
Right here. A function and its inverse is reflected across the line what?
Y equals X.
Y equals x. And then we drew this little graph here, and I talked to you about having to be 1 to 1.
It's like a mirror.
Yes. Okay, so
What if it touches that one?
It never will, Grant.
it does right here on this one.
Oh,
Okay,
whatever.
you're going to see. They will both touch that line at the same point. So what is the line?
Parabolas, Grant.
What does the line y equal x look like? What's the y-intercept of y equals x?
It's just
Zero.
zero.
Straight line.
You're thinking of,
Not a straight line, sorry, but like it just goes up.
It's just 1
okay,
over 1.
so 1 over 1 for the slope.
Or the origin.
So it
That's
starts
the
at
word
0,
I'm looking for,
it
boys.
just keeps going like that.
Origin.
All right.
Sorry, I was trying to gesture
It's like when you
this, but
play
I was
the
like,
origins.
it's like,
I'm gonna kill those 2 zombies.
All right.
And you get the staffs.
Stab the isolates best.
All right. So the pencil is f of x, the red line is y equals x, and the blue line is my f inverse function. Can you see that the pencil and the blue line are reflective across the red line? Yes? Now the question was asked, Grant asked, what if they touch the red line? Do you see that the two of them touch the red line at the same point?
yes.
All right. So, do you guys remember what happened with domain and range last week when we dealt with inverse?
swapped.
They swap.
They,
One's domain, F's domain becomes F inverses range,
and so on and so forth.
and vice versa on the other ones. All right, so let's take a look at a point. Pick a point. I'm actually going to pick one for you. This point right here. Can you guys look at this point on my FX line? Can you figure out what that point is right there? Can you guys calculate it?
3, 1, 2, 3, 6. No, 5. 3, 5, bro.
All right.
How's that ball?
On the blue line, what point should that be if they flip-flop?
5, 3.
5, 3. Let's plot that 5, 3 and see if it's on your blue line.
Indeed.
Is it? Did it work? All right, pick another one on your f of x line. Let's pick this one right here.
That's 2, 3.
2, 3. So what should 2, 3 be on the inverse line?
3, 2.
Plot 3, 2 and see if it works. Does it? All right, even though those weren't lines or points that we plotted when we graphed, they're still on the line. Does that make sense?
Yeah.
Yes.
Will we get a chance to break any of these rules?
No.
Like, is there any
This is
exceptions
so
or anything, or is it
objective,
just like...
Not for inverse functions, no.
Where it's like, oh, there's rules. How can I break them?
All right, next one. Find the inverse function of f of x equals 2x plus 3 over 5. We're not going to graph. We're not going to sketch this one, but I do
Thank
want to
God.
find it just for practice. All right,
Wait,
y
wouldn't it be 2x
equals,
over 5 plus 3 over 5 equals y?
what was that?
So would it be just like y equals 2x over 5 plus 3 over 5, or no?
You can just skip over to replacing the f of x
Mm-hmm.
with an x and the x with a y,
Mhm.
right?
Yes. You can skip this step and go straight to x equals 2y. Is that what you're saying?
Yeah.
Yes. All right. And then you would solve.
Yeah.
Yes.
How do we solve this? Multiply both sides by 5x equals
2y plus 2.
Move the 3.
and then subtract subtract the 3 over. Can I do 5x minus 3 and get 2x? Are those like terms? No. So I write it as 5x minus 3 equals 2y, and the last step? Divide it by 2. Alright, f inverse of x equals 5/2 x minus 3/2. Okay, so I do want to take some time to talk about a type of test question you will see. So everybody should be paying attention. That means your phones are put away.
So like a word?
Okay, so here's the deal. I'm going to cover this. Let's pretend we did not find this. And all I gave you was f of x, and that was it. So all I gave you.
Wait, so we assume that we haven't done anything?
We're going to assume we haven't done anything other than given the function. That's all. We just looked at it. And it said, given f of x equals blah, 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 find is going to give you something like this. Actually, I'll make this up. Okay. Okay, now, I don't want to say it's a mistake, but where do kids mess themselves up? They look and they're saying, oh, well, this is asking about the inverse, and I don't have the inverse, so I'm going to find that first. Then I'm going to plug in 7 here.
But then you have to plug that into the
And then is this going to give me a fraction when I plug 7 in here? Yes, and then I'm going to get that fraction and plug it up here into another fraction. And does it get really messy really fast?
Yeah.
Okay, without any work, without a stitch, scratch of work at all, what's your answer?
Non-existent. Oh, yeah, so
Because we found the inverse, we know it has an inverse.
Right.
So
So
what if they were asking for not the inverse, but
it would be the inverse. All right, so back to this up here. This is always true with functions and inverse functions. Do you agree? So if I gave you something like that original, do I need to know its inverse to know that this is 7?
No.
What if I change that 7 with a -5? Your answer will come out to be? -5. Again, do you need to know the inverse function to know the answer here? Do you even need to know the original function? Technically, no, you don't. Because we know by definition that a function and its inverse composition is going to come out to be x, or in this case, 7.
Can I all do that question?
No. Oh, yes.
the question.
Yes. This is always true.
No, but I'm saying, like, you don't have to know anything else. Like,
Correct.
if you know the x,
Yep. If I gave you this, and I'm flipping it around this time, what's that answer? Still 5. Did you know what the g function was? No, but you know if you have inverse function, does it matter which one comes first, the original or the inverse? No. They undo each other and your answer is 5.
Say multiplication, right?
Yep. It's exactly what it's like. They undo each other like multiplication and division.
Where would we see it when it would be like that? You say if we know there's an inverse one there, right?
Say it again.
So like you say, right, if the inverse is present, then that's always going to be 7.
Even
How would
no,
they present it as a problem when it's not going to be?
like that. Given f of x equals 2x plus 3 over 5, find this. And you don't need to know the inverse function. You don't need to find it. You can, but you're going to be wasting time. The answer is just 7.
Okay.
All right. Okay. Next one. X cubed plus 1. Before we find its inverse, some of you may have already done it. What does this function look like? Do you guys know what the cubic function looks like? Yes?
It's the S, right?
Yeah? Is that what you guys said?
Tangent? I don't know. I call
It kind of looks like a tangent.
That's what I said like when we first did this stuff. I was like, last week.
All right.
And Mrs. Torres like, no, it's not a tangent.
It looks like, but it is not, because cubics get wider forever. Tangents don't. Well, they do, but they're restricted.
Yeah.
All right. What's my
What if you had a loose tangent?
How do I graph this, guys? What does a +1 do? Which way does it shift it?
Shifts it to the up.
Up 1?
It shifts it to the up.
What else that north was called? To the up.
To the up.
How do you know?
Let's go Clovis to the up.
Cubic
my
functions.
dudes.
You learned how to graph cubic functions last year. You did a whole bunch of reflecting and shifting and
But you know, we've all forgotten that now.
When?
last year, the whole first semester.
Yeah, I wasn't.
You have a swimming soon?
You weren't here for that?
No, I wasn't canceled in first semester.
Oh.
Yeah, I was there.
Oh. All right.
Just got super. I think she
Is
was.
there anything I'm kidding?
No. I thought you were kidding. I thought you were saying like you weren't paying attention.
No, actually, I wasn't there. Sorry, I don't even.
Okay.
Yeah, I'm
We should go.
Okay, guys, we're listening. Do you guys remember that this is what the cubic function looks like?
Yeah.
You do now. And +1 means it shifts up 1. We did that first semester with sine and cosine functions, yes?
Yes, it's always been known.
And it's always been known.
The information is there.
The information
It exists independent of your knowledge.
All right.
You know what it is.
Go ahead and find the inverse. Do that now. Flip and solve.
Wait, okay, so
Ma'am, could I use that piece of paper?
is math a separate physical entity, or has it been made up by man?
No, math is separate from man, dude. Man did not invent math. Information is not created nor destroyed. Just
Wait, let me ask you the same question. Is time
Is it
made
gonna be
up?
a cube root or not?
Yes.
as far as we know, it was there before us.
But you know what
That
it is?
it exists, but
So
we've labeled
many
it.
people say time is made up.
I'm not saying that, bro.
I know, but I'm just taking the argument.
The
without-
measurement. The
Well,
measurement of
man
time.
invented the man labeled it, but it
Tonka
exists.
time.
Yes. The measurement and labeling that was man, but
Yes.
it's always
It
there.
was always there, exactly.
All
Our
right.
universe is still governed by it to a degree.
All right. What do we do to both sides?
Change it.
This story's we need an astrophysics class.
Cube
Take
root.
it. You can.
All right.
Yeah, I always get confused with the cube root stuff in stories.
Yes.
Y equals the cube root of a big cube root and x minus 1 on the inside. Do you agree?
Oh,
What
so you
were you
said
saying
big
about the
cube
big
root,
cube
put the
root?
tiny cube root in the big
Yeah,
cube
that's
root.
what I'm saying. I don't get that.
Because this is what I was asking. Do I put the cube root over everything or just over the x when I cube
Over
root?
everything.
Over everything.
Oh, okay.
Okay.
I'm feeling it now.
All right.
Mr. Grinch.
Do you guys remember how to graph the cube root function?
No.
That's all I was saying.
Simply choose the right x values.
No one remembers? All right. Maybe when I graph it, you guys will be like, oh, yeah, I remember. So before we graph it, I'm going to make a T-chart, since we don't know what the graph looks like already. X and,
I know what it looks like.
do you?
It's like the x to the cube, but it's sideways.
Exactly. The teacher taught you guys like the Egyptian graph. Do you guys remember that?
Oh, yeah, okay.
Oh,
Uh-huh.
I
okay.
Mr. Kamose.
So it's like half an alligator.
So he's correct. It's the cube root graph on its side, just like the parabola graph flips on its side. Same thing.
Or
It's
like
the
all
cubic.
versus on their side.
Yep, exactly. And that's the whole y equals x reflection. All right, I'm going to continue. We're going to pretend we still didn't know what it looks like, even though Darren gave it to us. -2, -1, 0, 1, 2. And we're going to take that and plug it into the original. And there's a reason why.
So you're getting these just because these are your common 5 points.
Yes,
Right? I
yes.
remember these from like 8th grade.
Yeah, he asked why these points common 5 points, right? Yes.
Mr.
All right.
Davis' stuff. 7th grade.
Sometimes.
You remember him?
Okay.
His name was-
-2 to the third. Help me out. -2 to the third. -8
8.
plus 1 is negative.
7
All right. -1 to the third.
is always -1.
Plus 1.
0.
0 to the third.
1. Or no, 0.
Plus 1. You're ahead of me.
Oh, yeah, 1.
1. 1 to the third. Plus 1.
2.
And 2 to the third.
8.
8 plus 1.
9.
9.
What did you just do there?
I picked 5 standard points, -2, -1, 0, 1, 2,
So,
and I plugged them
along-
into this function.
So
the negative
Tyron,
twos and
a
it's
long,
supposed
long
to be
time
7.
ago, in a galaxy far.
It is. I just didn't write it
Tyron,
down.
Tyron.
When I wrote it, I went too fast. Sorry.
Are you guys talking about Star Trek?
Yeah, sorry. You guys said -7, at least I think everybody did, and I
Yeah.
just went too fast in my writing. My apologies, my apologies. All right, I'm gonna quickly graph the y equals x line, just because we know that it should be reflected across that line. There, there. And I'm going to connect.
Wait
Do you
a minute.
guys agree the y equals x line has a y-intercept of 0 and a slope of 1? Yes? All right. So let's go ahead and plot -2, -7. -1, 0. Ah, I messed up. No. Don't keep plotting, please, please, please. There was one piece I forgot to have you do. The reason I wanted to erase that, because these points here are just going to end up with this graph that I've graphed already.
Yeah.
Yes.
We just have to do the -7.
Now, how do I get the, I'm just going to make it a little more accurate. How do I get the inverse function? What do I do with the x and the y here?
You get your code in. No, I'm kidding.
How
Just
do I
flip
do it? I flip them. For the inverse function, we flip. Do you guys remember that?
Yeah.
Yes, we did that earlier here, x, y, they flip-flopped. We're going to do that with the whole domain and range now. So it's going to be -7, -2, 0, -1, 1, 0. And I'm going to give myself more room. Two, 1, and 9, 2. Now again, plotting these like I started to do is just the original function, which I don't need to do again. This one here is the inverse function. That's the one I want to plot. So I'm going to try it again. Yes.
Why wouldn't, for inverse, why wouldn't it be,
That looks tricky.
oh, never mind.
Never mind.
No, I thought that the inverse is like it's switched and then it becomes negative.
No.
Right?
You're thinking of maybe perpendicular, opposite, reciprocal.
Alright, like that.
All right. And it's kind of hard to see with these points, but Darren gave us the hint earlier. He said it's like this flipped on its side. I like to just turn it this way and then kind of follow those.
Trick down.
Yeah, I like flipping it because it's easier for me to graph my cubic graphs up and down than sideways, kind of harder for me. You do not have to use that trick, but that's just what I do.
I'm feeling it, Mr. Krabs.
Now, again, reflective across the y equals x line. Now, with that being said, actually taking a step back, was the original function 1-to-1, the horizontal line test?
Yeah.
So it makes sense that this does have an inverse. Here's the inverse, and is the inverse a function?
Yes, the inverse is.
The inverse is a function because the original function was a 1-to-1 function. Did you guys hear that? The inverse, which is this one side, is a function because the original function here that I had was a 1-to-1 function. Yes? All right. Knowing what we know about shifting, which way would this cube root graph shift? Knowing what we know about shifting, which direction would this cube to the right one? And can you see where this cube root graph did shift to the right one, and there it is graphed? Do you see that? All right, questions? All right, phones put away. Number 4, find the inverse function for f of x equals square root of x minus 5. All right, I'm going to have you guys do that one. Flip-flop and solve. All right, what did you guys get? X squared plus 5? Yes? All right, so
Last step.
what we did is we changed the f of x to y, flip-flop your x and y, solve for y by squaring both sides, then subtract your 5, or add your 5, sorry, x squared plus 5. All right. Do you guys remember what the square root function looked like from last year? Square root function, you guys don't remember? Half of a sideways parabola looks like this.
Yeah.
Kelly doing the moves.
What?
Half of a sideways parabola.
Oh.
Huh?
Yeah, so I'm just gonna study the way.
Okay. All right. According to what we know, I'm graphing this one right here, the f of x. Which way does this shift? Right 5, left 5, up 5, or down 5? Right 5. 1, 2, 3, 4, 5, and it's half of a sideways parabola. Yes?
How do we know which half positive or negative?
Yeah. Positive is the top half, negative would be the bottom half.
How do we know
I like
if
answering
it's
my own
sideways
question.
parabola?
For math 3,
Let's look at both.
first semester.
Good thing after 1 year's done,
You
put
guys.
it all out the chute.
So is this something you feel like we should have reviewed, all this original functioning?
Yeah,
Original functioning.
yeah.
Okay.
Only
School
these,
just
only
tells-
like
school just
some of
teaches you
these.
how to channel information for short periods of time and just throw it out of your head.
That is
Wait,
true.
so on the inverse guy, so is it's just going over 5? Or is he going up?
Okay, we're gonna get to that. Let me graph my y equals x line first.
So you don't have to go off any point, just do one and then the direction where it generally goes.
Correct. The only reason I did points on this one is because nobody remembered what it looked like, this Egyptian one. But it seems like you guys don't remember a lot of them, so.
You know it's alright. It's okay.
But now that we are reviewing, do you guys remember the square root graph is half of a sideways parabola?
I remember
Sure.
everything.
Now I know.
I
Now?
remember
Wait,
Okay.
I remember the moment
Yes.
I was
If it
born
was the
till
bottom
today.
half of the sideways parabola, it would be the negative would be on the outside of the square root.
Yes. Yes. All right. Are we good? So this one here, now, what was your question, Kellen? You said now this
Well,
about,
It's x squared plus 5, so is the plus 5 along the y?
okay, which does, what, in this one, what does the shifting do? Up 5, down 5, right 5, left 5? Up 5, right? Because it's not in parentheses.
Okay.
So it goes up 5. 1, 2, 3, 4, 5. And what shape is this? What is it?
Half parabola.
Okay. Now I hear you guys saying half parabola. Thank you. How do you know it's half parabola? If I just
No
graphed,
restrictions.
okay,
Because by
be-
definition, a parabola consists of two half parabolas.
all right, I'm gonna graph as we usually would because she said there's no restrictions. Do you guys agree that x squared plus 5 would be this graph right here? Now,
Oh, we're talking standard.
is this parabola a function? Does it pass the vertical line test? Yes. Is it a 1-to-1 function? Does it pass the horizontal line test?
No.
No, it does not.
What is the horizontal?
To test if a function has an inverse.
So
Because when you
you
do
would
it,
just
it's not
see
going to be a
if
function.
you do it the same way. as the
Yes.
line.
So you would do it this way. If it passes twice, it's not 1-to-1. And it would not have a function because what she said, when you flip it on its side, it's no longer a function. And here's why. Are these two inverses of each other? No, this one here does not have an inverse because when you flip it on its side, you end up with the whole shape. And is that whole shape a function?
No.
No. So what do we do with parabolas? We have to have,
So the horizontal
Special
line test is
horizontal.
just a vertical test if you flip.
yes. And they go together because
Just like this.
when you flip the 1-to-1 on its side, it becomes the vertical line test, which is testing for a function. All right. How do you know we need restrictions? Because according to this, I'm only graphing half. So my inverse should only be half. Knowing it's reflecting across the y equals x, will I keep the right half or keep the left half?
Keep the left half.
I want it to match. Keep the right and erase the left. Do you guys see that? Because I want it
That
to
is the left half. Oh, wait, no.
keep.
Okay,
I want
yeah.
to keep the right. All right, do you guys see that it's reflective across the y equals x line?
Yes.
All right, now remembering what we said about domain and range? Domain and range do what?
They swap.
They swap.
They go directly in a reverse.
So look at the restriction here. What would I say? X is greater than equal to 0 or less than equal to 0 if I'm keeping the right half? What would I say my restriction is? X is greater than or equal to 0. Why? Because I only want the right half, not the left. Does that make sense? Yes or no?
Yes.
If this is my,
Is that in your answer?
yes. If this is my domain for the inverse, what is the range of the original? If this is the domain of the inverse, what is the range of the original? Instead of x, we would use what? Because it's range. Y is greater than or equal to 0. Let's check that. Let's go to your original function. This is the original. Is your range y is greater than or equal to 0? I'm going to repeat that. Domain is x is greater than or equal to 0 for the inverse, which means for the original, the domain or the range should be y is greater than or equal to 0. Is that true for the original?
Yes.
Yes, it's above the 0. Y is greater than or equal to 0. Questions? All right, I'm going to flip this over to the,
Solid and purple.
sorry, flip it over to the back side.
Holy smokes.
All right,
You got some piece
sketch the inverse of the following functions on the same graph. All right, is this, first off, this test, vertical line test, is it a function? Horizontal line test. Is this function a one-to-one function? Which means the inverse does exist or does not?
Does.
Does. All right, I want us to quickly graph the y.
Can you repeat that?
Is it a function?
Yes.
Yes. Is it a one-to-one function?
Sure.
Yes, because it passes the one-to-one test, the horizontal line test, which means the inverse does exist. There is an inverse.
And then you gotta get your y equals x.
Y equals x line is what we're going to
Little
graph in there.
squiggly squigs here. Look at that straight line, right? Have you ever seen a line straighter than that?
Yes.
Nope.
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 All right.
My dad
Now-
has like an uncanny ability to draw straight lines.
I'm going.
Like $2 million a month just for that.
Well,
Just drawing
he's an
straight
architect, so pretty much.
I'm going to have you guys pick points because of what we know about domain and range. I'm going to pick 3 points that go through corners the best you can.
Wait, corner?
Yeah, like, you know, that are actual, not fractional intercepts.
There's 4 corners.
So, what is this point right here?
Negative 2, 0. Is that a corner? That's not a corner.
By a corner, I mean
That's like an 8 point.
okay.
Wait, so
A
you
corner
said-
by one of these
cross-section
corners.
of a grid.
Yes, thank you.
Wait a minute. No, like, I'm seriously like, can you...
Yes, like I don't want the point going like that. I want the point on one of my corners
Point
of
the arrowhead.
Oh, the small corner.
yes.
Like the tiny boxes.
Yes. All
In the
right.
middle or
Holy
on the line.
smokes.
What's this point right here?
Zero, two.
0, 2. And what is this point over here?
3, 3.
All right. What do we know about the inverse?
It exists.
Yes, but what's going to happen with my domain and range?
It goes flippity flop.
Do we have to do all this, or can we just eyeball it?
I'd like you to at least like get this point over and then eyeball it. You can do that. All right. 0, negative 2, 2, 0, 3, 3. Yes or no? Did I flip those properly?
Yeah.
All right. 0, negative 2.
But man, just know that you're flipping it under inspection.
3.
Please.
And I didn't just connect those 3. I actually went a little further to get more of a graph.
The curvature.
Yes. And does it look symmetrical across the line y equals x? Yes. Does it pass? This is not going straight. It's,
Slightly curved.
yeah, it's slightly curving forever and ever and ever.
What about the form that slightly curving forever and ever and
like a parabola. It's getting wider, but it's only half of
What
a
if your
parabola.
arm just slightly curved forever and over and over? So like your arm was just infinity. So you could just like
Slightly
go to
curved.
hit someone and you just be never be able to hit them with your hand. It'd always just be a piece of your arm.
Okay, number 6. Are we ready?
Slightly curved. So one of these days it'd like reach the ozone layer and it'd be like too late for your hand.
You could be able to put a
Okay.
cap on it.
Guys, on this one here, does this pass the vertical line test, meaning it is a function?
Indeed.
Does it pass the horizontal line test?
Big no, kids.
Which means it does not have
An inverse.
an inverse. We're going to see why. We talked already about it last week, but I'm going to show you again. Okay, I'm going to pick these 3 points right there. Can you label what those 3 points are?
If I wanted to.
Yes. Yes, you can, and yes, you want to.
3, negative 3, 2,
1,
negative
2,
4, 1, negative 5, 2.
Negative 5, 2, negative 4, 1, and negative 3, 2. Is that what you said?
Yes.
Okay, so I'm going to flip-flop them. 2, negative 5, 1, negative 4, and 2, negative 3. Can you guys plot those now?
Yes. Wait. Okay, cool.
And I forgot to draw my y equals x line.
See, this is where I have an inspection. This is
Nice, Lou Grant. Thank you.
So you're drawing
He's
that
trying out
line.
for
The y, yes, the y equals x line, yeah. Every inverse should be reflected across that line. All right, knowing what we know, that's going to look like this and like this. Now, can you see why the
It looks
inverse
like-
does not exist?
Yeah, it looks like, yeah.
Because this does not pass the vertical line test, which means it is not a function. So, the inverse does not exist because when you graph the inverse, it's not a function.
You're not a real function.
Function,
Not real.
but because it's not a one-to-one function, the inverse does not exist. This would not work. I'm not going to erase it because we're going to work on that for part number 8.
Part number 8.
Part number 8. All right.
How many parts?
Last one. T-chart.
Grant?
It already has the 3 points marked for you. Use those 3 points. It has the 3 points marked for you. Use those 3 points. And you have one like this definitely on the test.
Unfortunately, there is a test.
Always. Oh, the quiz is tomorrow, by the
Unfortunately, there
way.
is an unfortunately.
The quiz
Group
is
quiz or
tomorrow. This is the
single quiz?
bigger one, the group one.
Thank goodness we got 2 geniuses sitting behind us. It's always our backup.
All right. What's this point right here? Anybody have it?
Go ahead, sit.
Yeah, Kellen, you're with us.
Thank you. -2, -4.
Right there when
At
I
least
do my
someone is
line,
listening.
somehow like I miss completely. And
It's
This
2-1. I
one?
know
like
that
two
one.
like little lines like right next
2-1,
to each other. It looks
thank
like
you.
railroad tracks.
Can you guys figure out that one right there?
It's like 2 plus 4
I'd
is
say
like
that's a
6.
6-2.
That's a 6-2, my dude.
6-2. And then flip-flop them, and don't forget to do your y equals x line.
I can always forget.
Oh, I actually wrote 22 instead of -2. Nice.
Okay, I don't know about you, but I'm feeling 22.
I know about you. I'm feeling 82. Getting tons
Yes.
of senior discounts. Oh, Obama.
Is this a parody?
Wish I was
Okay.
82.
Yeah, man.
I wish I was 80.
It was just like
You're just
All right.
spot on, man. I didn't
Guys, because we know they're broken up in pieces, I suggest you connect as you go. And then do the last piece. 2, 6. 1, 2, 3, 4, 5, 6. And then connect those two. And see if indeed it looks reflective across the red line. Does it? Yes, definite on the test. Questions on this one, yes or no?
Are these on the test?
All right.
Nope.
There is no
No.
test.
All right. Questions?
Legitimate questions? No.
Okay. Number 8. One of the functions in 5 through 7 was a many-to-one function. Oh, which one was it?
6.
6.
Wait, no, 5.
Okay. Restrict the domain in a way so that it is a one-to-one function and an inverse function would exist. Write out the function, its restricted domain, and the inverse function. What is the domain of the inverse function? A lot going on there.
Make it like square root.
Okay.
That way you don't have to even.
I agree there's a lot of words. We will have to restrict this so that the inverse will be the square root function, yes.
Yeah.
All right.
Do we just change the function, or do you have to restrict it? 'Cause that's
I
a
can
lot
draw
of,
right now. Like I
a
can
lot
draw.
of.
We're just going to restrict it.
Okay.
Okay, so what is this? 1, 2, 3, 4, left
5.
4, and up what?
1.
Now, we have to restrict it. Restricting it in which way? How do we restrict parabolas so that they are one-to-one?
You cut off half.
Cut off half. Does it matter which half?
No.
No, typically we cut off the left and leave the right so it looks like that.
So
But you
I'm
could
comfortable with that.
you could
Should
do
keep it
that
like-
piece.
Should keep it like that.
Okay, keep the right up. 1, 2, 3, 4. Should it be 4?
Yeah.
Thank you. And we said we are keeping the right half?
Yes.
Okay, there's the y equals x line. And this one over 1 down 1, 2, 3, 4. Now, because of this restriction, which half of the sideways parabola will I have? The top or the bottom? I want it to be reflective across this line, top or bottom.
Be the top. Wait, no, yeah.
No, you're right, the top. Okay, are they reflective?
Yes.
Okay, so what is the restriction then? How would I write this restriction?
Be like x is greater than -4.
Greater than or equal to -4.
Yeah,
You're
my
right.
Bad, my bad.
Because 1, 2, 3, -4, and I
it's
only
still there.
wanted it to the right, not the left. So x is greater than or equal
But
to
it's still there.
-4.
Yeah, my bad.
Does that make sense?
Sure.
Okay. What is the domain of the inverse function? I'm going to cover this and ask that we find it without looking at the picture.
Wait, but on the test, won't we have like drawn the
But do we have to? What if they don't ask us to? Do we have to?
Be real.
So what is the
Save an
domain?
extra second.
What do we know about domain and range?
They're like opposites.
Opposites.
So instead of x is greater than or equal to -4, the only thing we change is x to what?
Y.
Let's see if that works. Let's look at this and check if that is the domain. I'm sorry,
Range.
range. Okay, I did label it incorrectly.
That's okay.
Thank you for being understanding.
My 4 looks like I drew.
What was that?
As Hannah Montana says, everybody has those days.
Thank you. All right. I still do want to find the domain. I'm still going to cover this. And what do I know about domain? Domain of my inverse will be the what of the original?
Inverse.
Domain of my inverse will be the domain or range of the original.
Wait, oh, get the range.
All right, so let's find the range. Let's pretend we didn't have this one graphed down here. What is the range? Y is what? Greater than or equal to what? Range is the Y values. Range, Y is greater than or equal to 1. Yes or no?
Yes.
Do you guys agree that the range here is Y is greater than or equal to 1? Yes?
Yes.
So what should the domain be? Instead of Y, it's going to be X is greater than or equal to 1. Can you verify that with the graph? Is your domain X is greater than or equal to 1? Yes. So when you're asked that question on the test, if you don't have this graph, do you need it in order to find the domain? No, because you find the range of the original. Will it equal the domain of your inverse? The range of the original will equal the domain of your inverse. And that's what it was. Find the domain of the inverse function. Make sense? Yes or no? Can anybody find the range without looking at the... This is the domain. What is it? Y is...
Greater than or equal to -4.
Yes, so we just changed the X to Y. And is that true here? It's
Yes.
greater than or equal to -4. Yes or no?
Yeah.
Questions?
Did you put that up there?
Mhm.
Like I'm trying to... Oh, I Let's see. I got big.